All right, the last bit of your notes, we need to talk about uses of radioisotopes and how radioisotopes actually are very important to man. The first use we have is dating. I'm not talking about going out on a date. I'm actually talking about finding the age of something. We most commonly use carbon-14 dating. But this can only be used with things that are living because living things are carbon-based. I know we've talked about that before. Basically, the idea is when an organism is alive, the amount of carbon-14 that it has inside of it is pretty constant. But once it dies, the level actually goes down. So we can actually predict how much it should be based on that half-life of carbon-14, which is pretty long. This is useful to dating things to about 22,000 years. Beyond that, we have to use some other dating technology that we have. We can also use radioisotopes to tell us how old things that were never living are, like rocks. Okay, but because they were not living, we can't use carbon. One of the most common things that we do is we compare the amount of uranium-238 to the amount of lead-206 that's in a rock. Based on that ratio, we can determine the age of a particular rock that has been found. The second use that we have for radioisotopes is as a chemical tracer. And chemical tracers, what they do is they allow us to follow the path of an element through a process, or for instance through a body system. So we can actually find out how these different processes work, like in physiology. Basically, these chemical tracers allow us to detect if they are present or not. Some practical applications of this are things like phosphorus-31 is used in fertilizer. So we actually use this phosphorus-31 within the fertilizer industry to help farmers determine when is the best time for them to actually apply fertilizer. Fertilizer costs them money. And what you want to have happen is you apply the fertilizer and then the plants take that up. They need the phosphorus in order to grow as part of their DNA. You don't want to have the fertilizer get applied and have it, get washed away or have the plants not use it. We also used carbon-14 to help trace the different steps of our metabolism. And you'll learn some of those processes and cycles next year when you're in biology. Radioisotope use also has its place in industry. Now, there's two different things we typically use radioisotopes for within industry. We measure the strength of different materials, or we can measure how thick something is. What we do is we strike the material with the radiation, a given amount, and we measure how much comes out on the other side. The more thick or strong it is, the less will come through. And we typically will use this, for instance, welding. We can measure the strength of a weld. It's one of the things that they do when they do like bridge inspections. They will actually test those. We don't want bridges collapsing, so that would be a bad thing. We can measure it using radiation. Even things like saran wrap or plastic wrap that you have at home. At the factory, they want to quickly measure large amounts of saran wrap to make sure it is the proper thickness so it works correctly. They can actually use radiation to do that because, if it's the right thickness, they should get a certain amount of radiation coming through on the other side. And I know so examples are welds and the thickness of plastic wrap. I know throughout this unit I have talked about some of the medical uses of radiation. It can be used as a tracer or detector to help doctors diagnose problems, and it also can be used in the treatment of disorders or diseases. In addition, there are certain instruments or materials that we need to make sterile for things like surgery. Basically, sterile means that it's free of bacteria and other disease-causing organisms. Sometimes we can treat these in something called an autoclave, which is a sterilizer, but sometimes there's certain products that we can't do that, and we can actually use radiation to do that. Stick them under UV light, kind of like our goggles. Our goggles would melt in an autoclave. Now, the key with the medical use, as I've kind of been talking about, is that they have to have a short half-life, which we talked about why, because we don't want them to stay radioactive very long because they can hurt us. We also want to make sure that they are a type of material that will get taken out of the body very quickly. So if there's any that happens to be left over, it's not hanging out in the body causing more problems, because that's going to damage our healthy tissue. Some examples of things that we use in medicine are things like iodine-131 we use to treat thyroid cancer. Cobalt-60 helps to eliminate cancer tumors. And technetium-99 helps us to detect cancer.